community by addressing issues of the day. We have a number of a series of series, as I like to say. And if you take a look on the back of your green sheet, you'll see that we have the Innovation Catalyst Award. That is our annual event, and that happens in October, November. We just had an event honoring the Draper family. We have events that connect investors with limited partners, events that connect investors with entrepreneurs, and events for sharing information. Those are our workshops and SIGs. This is one of those. I'll just leave you to read this. This is we have 4 elevator pitches coming up in December. And an elevator pitch is where entrepreneurs pitch for 2 minutes. They get Q&A from the panelists for about 5 minutes and feedback for about 5 minutes. And then there's voting. The elevator pitch plus, instead of having the event start at 6:30, it starts at 5. And you get an hour with one of the managing partners, and anything you wanted to find out or learn about funding, how to relate to VCs, any questions, you just bring those to the table, and that has been very, very successful. So without further ado, I'm going to turn the floor over to Charlene.
Thank you, Jan. Thank you so much for all your great work, too, in the community. So I'm Charlene Yvonne. I'm the co-chair of the VCtaskforce SIG for Corporate Venture Capital event. And my partner in crime is John Clark, who was here a moment ago, but I think he had to take off on a conference call. But we're honored that you're here. I'm the CEO of a company called the Algonquin Group. We help American companies expand into Asia, and Asian companies expand into the U.S., and there's a number of folks that we work with here. We work with large multinationals as well as privately funded companies, so VC funded. And this event is also in conjunction with AMA, and we have some distinguished AMA board members here, like Robert Lee, who's joining us. I think you win the prize coming from Hong Kong, so you might win the prize for coming the furthest. But AMA is the premier Pan-Asian Technology Association. And we have chapters in Beijing and Shanghai, in Pearl River Delta that Robert just opened, in Seoul. And we have members throughout the technology community here in the Silicon Valley. And we work in conjunction with June and VCtaskforce to throw these events. So this evening, since big data has been a topic that Matt Sorrell and I have dealt with for a long time now, I've invited Matt, who is a well-known analyst, to come and moderate our panel, and our distinguished panel will be introducing themselves shortly. What I wanted to do, just for a show of hands, to give everybody a feel for who's in the audience, I just want to get a feel for the executives in the audience. How many people here are from venture-funded companies or entrepreneurs? Great, good. And I'm assuming in big data-related areas. Good. And then how many people are from that are investors or from large corporations? Anybody? Good, good. And then any other groups that I missed?
Techies.
That's everybody in the room. Any other groups, service providers? Yes, good, great. Well, without further ado, Matt, that's your audience composition. I'll turn it over to you.
Okay, thank you, Charlene. Bring my wine.
Oh, there goes the panel.
Actually, I just saw The Avengers, the movie The Avengers, and I have to think that you people want me to drink this wine. Okay, so. Well, I guess a bit about my background before we start. I actually started working with big data. Charlene's heard my joke a million times. I now know that I'm getting old because I've been working in big data since it was called data. And I actually have a very data-driven background because I started my career doing IT support in a medical research setting. And then I went and got a master's degree in epidemiology. So this is a field that's like almost entirely data-driven for several hundred years. So it's been interesting to me to see now other businesses becoming data-driven. And I guess so to round out my introduction of myself, since I left healthcare, I was at a few startups, and then I was at PC Magazine. I ran half the test lab there. The business stuff, like software, hardware, servers, networking, things like that. And since I left PC Magazine, I'm running my own company, Sorrel Group. We do technical marketing. And I also write for GigaOM and eWeek and the Internet.com franchises and things like that. So I have this perspective of big data sort of as a user, a consultant, and then also as someone who's getting called on right now to explain what is big data and why does it matter. And so that's why I was very happy to run the panel when Charlene and John asked me to. So if we could each introduce ourselves.
Sure, I'll go first.
Okay.
So good evening, I'm Mike Maxey. I work with Greenplum. We're a division of EMC, so it's a big storage company if you're not familiar with EMC. Greenplum is a software company. We build a big data platform, so it's a MPP database and a Hadoop distribution, sort of a collaboration platform. Been in the big data space, not quite as long as you, it sounds like, but for a number of years. My job there, I'm part of the corporate strategy team, a corporate development team. So we look to kind of the future, where we invest, who we merge and acquire, and those sorts of things. We actually announced an acquisition today. And just happy to be here and looking forward to the conversation.
Cool.
I'm Gina Tomlinson, and I work for the City and County of San Francisco. We do lots of things. But frankly, we're just really getting into the early stages of modern data management, big data. So the great thing is that we have a crap load of data. We have lots of data. Now we're getting into the science of managing. So this is an exciting time for us to get into this new foray of taking data and recycling it, repurposing our data, is what we like to call it. So it's an exciting time, and we're happy to be a part of it, and I'm really glad to be here tonight. Thank you very much.
My name is Leon Fong. I come from PG&E, Pacific Gas Electric Company. So I was actually here about 2 years ago on the panel of Smart Grid in China. So very glad, and thank you for inviting me back. We have a lot of data too. We have three business, if you look at the business of utility, we generate, we buy, and then we transmit, distribute, and then we serve and bill customers. Each of those cycles have tons of data. And what to do with data is kind of many times kind of like afterthought. And we're definitely running the current infrastructure that we work. And we recently have, we call it Internal Data and Analytics Data Warehouse Initiative, try to build a data warehouse to house all internal data and other customer information for analytic purposes. So, glad to share the lessons learned with all of you.
You have a lot of machine-to-machine data. I would think probably more than most industries, right?
Exactly.
Right.
Hi, my name is Mukund Chavan. I'm with a company called United Layer. We're a service provider. I run software there. So as a service provider, we see a number of types of customers, from city governments to small startups to ad serving networks that utilize different technologies. We have a unique perspective in the fact that we can work with these different types of customers and put together solutions all the way from efficient server architectures, networking architectures, and all the way up to putting together solution stacks that integrate different software and deliver them in a manner that is provides business value because IT is usually a cost center, so we try to make sure we give them very efficient architecture. So I kind of bring the service provider perspective. My background is in chips, so I used to design CPUs and DSPs, and then did software, so I can bring that end-to-end stack perspective. So I'm happy to be a part of this. So thank you for inviting me.
Sure,
Okay.
take it over.
All right, let's have fun. So to start sort of generally, which trends are getting the most attention from you in your position with regards to big data? You know, it's a big buzzword, and I understand that you could have a million things to answer, but like, what if you could just pick one or two sort of, you know, important trends that you're focused on right now that would probably be helpful? Who wants? I'm going to call on Mike first. He's made the most eye contact. Yeah, exactly.
That's only on Southwest Airlines. So, you know, I think it's a very relevant question. I guess the two that I would follow, I think the interesting ones are applications. You know, things are moving up the stack. I think applications are really interesting. You know, if you look in the Hadoop space, companies like Platfora, I think is a very interesting thing just announced recently. And another one I like is Decide.com. I don't know if anyone's familiar with that one. It's a consumer app that leverages big data to help you decide, should you buy a new cell phone or should you buy a new set of headphones, these sorts of things. And I think it's a really interesting look at price trending and sort of packaging very simply that, you know, looks like my mom needed to use Decide.com and other big data. So I think that's very interesting. I think there's a lot of innovation going on in the application layer, taking advantage of these architectures. The other is sort of the privation of languages and tools. So if you think about Hadoop, I don't know who's familiar with Hadoop in the room, but very powerful but somewhat immature technology. And I think you're seeing a lot of investment in making that easy. You know, things like service offerings. We were talking a little bit earlier with Ruben about that. But also sort of tools coming out of like SQL and things that have been around for 100 years that make lives easier for the enterprise. So I tend to focus on those areas.
Mm-hmm. Okay. How about Gina?
For us, it's kind of our focus has been, we kind of followed the mandate from the Obama administration back in 2009 to make our data more transparent, to open up the data to our taxpayers and citizens. So upon that mandate, we made a concerted effort to bring forth data that we have, data sets that we have in archives and various databases and various systems across the city, to put pertinent, reliable, viable, tangible data available to the constituents in the city and allow them access to it. So that's been a real huge focus for us. There's tons of data available out there. Another thing that we're preparing for also is in light of the upcoming healthcare initiative that really goes into effect over the next couple of years is with healthcare. We are working to ensure that our data, our healthcare data at our hospitals and local hospitals around the city, that the data is secure, that the data is transferable and portable in a secure, robust manner. So those are the two areas that we're focused on in the city in terms of our big data initiatives, ensuring the security of the data, but also ensuring that it receives a level of visibility, the right level of visibility that doesn't compromise the data or compromise the citizens.
I think that may be an important listening to Mike and listening to Gina.
Yeah.
I'm thinking that this taking huge volumes of data and getting them into a format that an end user, a business user or a citizen, can easily look at something and understand it.
Yes.
That's going to be that's of major importance in this whole sort of big data movement.
And that's huge, making it tangible and pertinent to the everyday man. And so opening it up and making it usable in a way that they can use in their day-to-day operations. Where's the newest daycare center? Where's the closest library? Where's how do I get my permits? How do I get my phone turned on? Having that kind of data that just sits in various city repositories today, and having that open and available for downloading and further app development, that's kind of what I meant by recycling and repurposing data for greater good. So
That's great. Do you work with Code for America?
we did.
Yeah,
we
we're
did.
sponsored those guys.
We did.
It's good stuff.
Very good stuff.
What's Code for America?
I'm probably not going to do it justice, but it's a nonprofit that is sort of designed to take public data sets and improve the lives of the citizens. So they do things like take bus schedules and on-time routes, and then publish it into an iPhone app so that you know when your bus is coming.
And we encourage the use of again, repurposing of the data, reuse of the data for business use or daily use of your day-to-day comings and goings. So,
Right.
yeah, so it's a really neat way again of leveraging very simple data that's already there, not a huge resource-intensive type of work, but just leveraging resources that are already in place. I'm sorry, we're taking a little
We're talking.
I actually saw people wearing Code for America T-shirt in down San Francisco street.
Yes.
And I Googled for it, and I saw, explain Wikipedia as the techies way of contributing to the nation instead of not in the army.
Absolutely.
Yeah,
Absolutely.
so that's great. We also have that kind of like opening it up for public access as well. One initiative that's very exciting is the green button. It's being pushed. It was pushed by the previous CIO of the White House to open up the smart meter data to anyone who want to download it. Right now, it's still pretty clunky. You download XML file and you upload into another startup company or software company, online website, and then it processes it back to you. White House had an app competition earlier this year around summer, so 165 apps were submitted. Very exciting stuff. We're in a process of making the data more readily accessible. The current infrastructure doesn't allow that to happen. So with the new data warehouse, we're hoping that can enable more people to download their data and to find how they're consuming their energy and how they can conserve energy. The other trend, big itself, is just the analytics coming to the energy utility business. There was a Green Tech Media event this August in San Francisco. All the major players, IBM, EMC, Teradata, Oracle, were there. One startup company who has already been working in this area for about a year, he said he's really excited. Half a year ago, nobody was talking about analytics in the energy industry. Now all of a sudden, all the big players are here and they're trying to acquire companies, acquisition. But at the same time, he's afraid because so many competition from these big companies. There are niche companies in niche markets where these smaller companies definitely play into. There are also areas where the bigger companies can play into. I'll talk a little bit about that in a later question. But two of the major aspects of what are the analytics really adding a lot of value. One is customer analytics, knowing what customers want, building a 360-degree customer view of when customers call in our call center, we know exactly what they went through. We don't have to ask all the questions in the beginning. The second one is the outage management, grid management. So, one example is I live in Berkeley. So about a couple months ago, the light went out. So I checked my cell phone, pg&e.com, and there was a map, an outage map, that says North Berkeley, 9,000 people out of power. The crew is on its way. So I definitely feel good. I know that they didn't know and they're coming. A lot of times they will give you a time estimate of when the power will be restored. So these areas are definitely areas to focus on.
So as a service provider, we kind of follow the customer trends. So we see our customers' explosion of data that they are going through as we provision storage for them. We see both structured and unstructured data. And some of these applications that the panelists mentioned, our job is to try to figure out what are the efficient architectures we can put underneath to make sure that they can, write the applications that provide the fastest throughput, and that includes just the entire system, which can include the server architectures. Is it bare metal? Is it virtualized? What kind of CPU? Is it 4-core, 6-core, 8-core? Do we need DDR3 single rank DRAMs, as well as networking architectures? How do we put together Hadoop deployment that's maybe one network hop away from the eventual application that's using it, so we can get better throughput? So those are the kind of trends we look for to make sure at least the applications that delivering value is doing it in a manner that is very cost efficient, so they can scale out.
Actually, we could go right to my second question then, which is, this was a very good transition, thank you. How has the evolution of technology, right? So we talked about the software, right? Customers see the software, but everyone else has to kind of deal with what's underlying. So how has the evolution of networking, server architecture, and software now, how has that changed or helped us get ready for this explosion of data?
So I can go first. So Hadoop really allows you to do the function of MapReduce, and then structured data like things like software like Greenplum really allows you to do the analysis. So at the technology level, obviously from a CPU point of view, we see that there's parity in terms of real balance between, let's say, the number of cores as it goes from 4 to 6 to 8 cores, to the memory architectures, whether it's going from DDR2 to DDR3 to DDR4, which really lowers the overall server power or wattage. And then you get down to bus speeds, where can you feed the memory subsystem, the CPU subsystem in a manner that's consistent, that can keep up, so you don't, overall utilization of the system is kept at a very high level. So we looked at things like bus speeds, PCIe 2.0, PCIe 3.0, and eventually all the data now lives on disk. So now do we look at, for cheap systems, cost per gigabyte is very still a big important factor. So for Hadoop, people still want SATA disk, 7200 RPM, but we're looking at trying to feed this, CPU cycles and cores, so and faster buses. So as cost per gigabyte for solid state actually goes, at a point where it's affordable, then we can look at different architectures. So maybe not as disposable because the disks don't fail as often. So that how does that entire system look like? So from our point of view, really look at the nuts and bolts of, how it makes the eventual transition of the application, and that's kind of our technology trends that we follow. Is PG&E going to have an outage? Should we have a dual system or not? So we worry about all those things. Those are the kind of trends that we follow.
Get a microgrid.
Yeah.
Avoid you from outage. So on the one hand, the technology that's generating a lot of data, smart meter, home area network, in the future that your refrigerator will be able to connect to online and talk to your service provider, being a PG&E or any other company, and sensors, line sensors on the distribution transmission network. That's capturing data in sub-seconds. And what do we do about it? Do we have need to make centralized decision or more distributed decision? On the other hand, on the data storage and application, we're seeing definitely hardware become cheaper, volume larger. The deployment of appliances have become much easier. For a large company like PG&E, we look at Hadoop and we look at the more like appliances ready to deploy. The preference right now is to use appliances. Hadoop has its advantages in certain areas, but I think right now it's not mature for utility to adopt that. And also we look at the peers. Most of the peers have adopted appliances, this kind of solution. The other trend is the SaaS software as a service. We're working with OPower, for example. Some of you, if you are being served by PG&E, you'll see that your bill insert or a separate mail telling you how does your energy consumption compare with your like neighbors. That whole thing, from capturing, we send them the data, they analyze it, they print out the mail, they send it out, they collect the feedback. It's all done by a company in Colorado, OPower company. At the same time, this is a blessing, but at the same time, we have a few SaaS companies like this. It's becoming operational complexity for us to transfer data to them, transfer backwards, coordinating the few of them to make sure that they don't contradict each other. That's something that we're constantly working on. It's a challenge that we have to deal with.
Well, certainly the hardening of the back end infrastructure to support big data is an obvious need, and you must build up your infrastructure in a more robust manner to handle the amount of data. But I think probably one of the biggest technologies that's impacted now by the big data emergence is modern data management. How to manage the data, how to access the data, make it more easily accessible, make it more readily available to folks. We certainly want to have the right tools in front of people that they can use to manipulate the data, parse the data, index the data. So we having a great back end of infrastructure. Being an old infrastructure person myself, I totally appreciate that. But the interface to the customer, the interface to the user, and making tools that will allow an easier customer user experience in accessing data, that's going to get people coming back for more. That's going to get people to actually use the data, leverage the data, again, for whatever their business purpose is. So we're leveraging various tools from an MDM perspective to allow our citizens to better view and have access to the data.
What's an example that's been most effective in bringing that to the public?
Well, we've built we do a few things. One, we encourage a lot of app development with a lot of open data that we have available. We've made available in our data sets in our open data SF portal. So we really encourage app development, mobile development in that area. We also leverage various from our business partners, various MDM tools from our esteemed colleagues here and from some others, some of their colleagues, some of their competitors, and just leverage some of those tools again to be the face of the back end, to be the face interface with the data, pull the data up in a way that allows us to manipulate it better. And it's bigger than BI. It's more intrusive than that. It's more it really digs deeper into the data than that. But we want more. People want more than just dashboards and statuses. They really want to manipulate the data, take the data and conform it and use it in another way, more creative ways. So developing tools that really massage the data, manipulate the data, that's the next trend. Again, having the back end we got to have that anyway because things are getting bigger and bigger and bigger. But we have to, the technology now has to be how this data interfaces with the customer. What tools can we do to make that user experience more enjoyable?
So yeah, I'd agree with sort of everyone on the panel. I think fundamentally big data is big, and one of the challenges of it is moving it around, right? And I think if you look at classic architectures, which my company was built upon, EMC, it's about big beefy storage boxes and fast pipes between it. But when you get to petabyte-sized repositories, you can't move that stuff around. So what's changed is you push processing to the data rather than data to the processing. And I think that has driven a lot of technologies. So things like Arista, which is very, very good scale-out switching, CPU and memory, and then the software architectures. I think that we've mentioned Hadoop a bunch of times, but I think the fact that it's open source, it's very scalable, it's built for this distributed processing, is kind of driving the way the adoption happens. So it's a number of factors, but from my view, I think software is a very, very important part of it. The other is cloud. I think more and more folks are getting comfortable with the idea of some parts of their data publicly available out there and being able to spin up processing up and down based on the needs of the business. So I think that's an important characteristic as well.
Well, we touched a little bit on concrete examples of the benefits of big data. Gina mentioned some stuff. I don't know. Let's hear more from Leon about smart grid and benefits of big data analysis. So as from the aspect of the business doing the data analysis, like we understand a little bit of the customer benefits because we deal with it. You know, we go home and get our bills and look at them and stuff. But how does gathering and analyzing all this data help PG&E run your business better?
Sure. One area of very interesting is the asset management. So we have many transformers. Some are mounted on the pole, some are underground. The average age of our transformers are 44 years. Right now, before about a year ago, we didn't have a way of telling, so we rank, which one is more longer age, has been there longer. And now with the smart data, we can aggregate the information about the load of this specific transformer that have a few homes connected to it, and we can tell what's the peak load. We can also throw in other data like the weather, sensing information, the outage information, so we can prioritize which one we should send a crew to and fix it early on. So something like that we've done before. Another observation is, we built some of the databases or data warehouses we built before. It was only like looking at one source of data. If you were looking at the sensor data, you just look at sensor data, and there was no capability to throw in other data. And now we realize, the value is generated when you put multiple sources of data together. There are companies in the Valley that are looking at GIS, using GIS visualization to, they're calling it the situational awareness. So in the transmission map, you can see where the fires are, where the wind and sun, the weather patterns are, and where your transmission are likely to go wrong, so you can be more proactive in terms of protecting
yourself. Who else has a concrete example?
Yeah, again, I'm talking about it again from an infrastructure perspective. So when we looked at a big data solution initiative that we had, we wanted to see if we could come up with an architecture that would provide the best benefit in terms of cost and scale out. So we put together a solution that has a mix of virtualized and bare metal platforms, and we did an experiment to see whether we can put it on 10 gig or 1 gig networks. And we had two customers. Both of them were running different types of applications in their public infrastructure. And one was more data mining, was kind of an offline mining algorithm. And another one was real-time, where they're trying to do real-time bids for ads. So that was a business, to be able to make sure they bid for the appropriate ad, get the impression, and then they get paid. So what we found was for the company that was doing the more offline data mining piece of it, they really thought they needed, their application needed 10 gig networking. And they thought they had to deploy a 10 gig cluster in the cloud. So what we did was we put together kind of an A/B test for them, where we were able to show that for their application, what they really didn't need was a 10 gig network, but what they wanted was more CPU cores and more bandwidth to the local memory, and they can just get away with a really cheap 1 gig switch. So they're able to dramatically reduce their cost, because per port cost in 10 gig is still $1,000 on each side when you want to connect when it's loaded. So that's one concrete example. We're going to lower the cost of compute for the data mining. So they can put more Hadoop nodes and then kind of put more throughput through the system. So that's one thing. Second thing is what we found is this other company that has ad networking was in the cloud. They had their business intelligence somewhere in a cloud instance. They had their Hadoop also somewhere in a cloud instance. And we didn't know whether some of the workload was virtualized, some of them was not virtualized. We actually went in and said, okay, let's virtualize these systems, let's not virtualize these systems, put them all in the same network domain. So what they found out was that they had a dramatic decrease in their response time when they were able to respond to their ad serving network from 100 milliseconds to 20 milliseconds. That's a 5x improvement. And also on a 1 gig network. So this is kind of an example of how we can build platforms that can deliver value to a customer, so they're not spending money on just the hardware, but at writing an application and delivering value. So those are real A/B tests that we did that delivered value to the customer. So they obviously switched to our platform rather than sticking to
I have a question that's for Gina and Leon, especially since Matt's family is in New Jersey and he just experienced and went through all the trauma of Sandy. And so you both are actually in prime positions to talk about how can we leverage the technologies that we know about big data and our capabilities to be able to be more proactive in scenarios like that. To me, I learned so much just watching what happened to you to make me think about what do we need to do here from a technology
The most
standpoint.
fascinating thing was that the power company wouldn't say when things were going to be fixed. So you're talking about this outage management. So the answer was, it's broken. It'll get fixed. And actually, what ultimately happened was that Governor Christie gave a press conference and he said, we're not going to tolerate this. Like, if anyone calls the power company and the answer is we don't know, you get your power back when we give it back, I want you to call this hotline and we will get an answer for you. And apparently that was the only thing that actually got the power company to give people answers, because maybe they don't have an outage management system. I mean, I can't talk about what they have or don't have, but now the idea of like, oh, that transformer's 44 years old, maybe we should repair it before something goes wrong with it. That, those are like...
Or even his app that said that it's out in 9,000 homes and it's going to be up in 44 minutes or whatever it is. I mean, that would have been very beneficial for your family.
For the first, until their batteries die.
Yeah,
But that sort of information, on a citywide basis and on a utility basis, is very valuable.
Yeah. So I think one of the major reasons that the outage happened is because of tree vegetation. The tree fell on the line, and safety, and all the issues.
Or actually, the wind just snapped a lot of the utility poles.
Exactly, and there's always a debate, public debate. If the utility try to keep the clean, how many feet from the transmission line. There's always debate between the community and the utility companies. That's one thing standing in the issue. The other one is, we're also experimenting with the technology to isolate the area, quickly detect the area that's outage. So we have a recloser that's close down and then to see whether there's a problem in it, and then quickly open up again, test a few times to see whether we should isolate that area. That's another thing. I can't speak to whether the Long Island utility company have that, but we're just also starting to experiment with that technology as well. We're really hopeful that will definitely limit the issues like Sandy caused this time. The other big lessons learned is just having, if your data is very important, your infrastructure is very important, like hospitals, data centers, have your microgrid, have your power generation. That's gonna save you in that kind of circumstances.
Mm-hmm. Well, there were hospitals had a lot of businesses, and they call things mission critical, and then have their own grids or cogeneration or whatever. But it was like people in their homes who had no electricity. But it's good to know that there are ways to come up with answers. And I think actually you made an interesting point about just this idea of emergency management, which becomes sort of a city question now, of just informing everyone and in a way keeping everyone in the loop, kind of.
Well, I think transition.
Yeah.
The loop. The loop. That was a power joke.
I think that
Yeah. Especially because I pointed it out.
when we watch these natural disasters on TV, sitting at home and watching on TV, one of the main themes that you saw was amateur video, amateur communication, people texting, people using Facebook to communicate. I think that leveraging having social networking bleed into a business case now, truly bleeding into business use. I think that's one of the next phases of growing big data and growing communications and emergency management. Leveraging the opportunity for social networking vehicles to communicate, allow folks within neighborhoods to communicate with one another, allow hospitals and emergency response factions to be able to communicate within among themselves. I think leveraging those types of tools and presenting that, and presenting the type of statuses and intake of information is a vehicle to help with emergency management. And again, that's a kind of a constant theme that you see, a lot of amateur videos, and you see amateur cameras and all of that going on, where people are communicating what's going on in my neighborhood. I think that we would do well by leveraging that in some way, and parlaying that into our design in terms of and our process of how we conduct our emergency management and response actions. Now, additionally, and this is kind of under development right now. It's kind of stalled out right now, but there's a national effort underway to develop a private public safety network for folks for first responders, where they alone have access to a particular band, where they alone can traverse data, voice and data that is isolated and exclusive to them for their use, again, to better respond, to better provide awareness, to better communicate when disasters occur. So I think, when we have these disasters, people, it's the necessity is the mother of invention, right? So when these kind of disasters occur, people come up with very unique ways to survive, very unique ways to communicate, very unique ways to do anything day to day. If we leverage some of that, make those things available on a more enterprise basis, again, via social networking or via tools that will allow a more broad access to those things.
So one thing that I sort of hear is the importance of user-generated data.
Mm-hmm.
So I think that's another sort of theme, that where data's not coming down as much. Like, it was smaller when it was, it's in a very abstract way of describing it. But if it were all coming from one central point, then it's not as big. And if we're pulling it all in from individuals or other businesses or like different databases, data sources, then it's contributing to the explosion, I think. I don't know, how does that?
Yeah, I mean, I think it's safe to say everything's interconnected. I mean, everyone in the room has a smartphone, I would imagine. It's Silicon Valley, right? And we're all just data producers now, right?
Mm-hmm.
I think that everyone to everything connectivity is proliferating. And it's been there a while. Most people just dropped it on the floor. But now you see, lower cost storage and all these platforms allow you to start keeping and mining and leveraging stuff.
And ways to actually like monetize the information or the decisions that are being made.
Absolutely.
Like, not just making it for the sake of making it.
Yeah.
Evaluation.
Yeah, we work, I see a lot of big data use cases in where I sit, but one of the more interesting ones is company CareCore. They do, they call it treatment pathways. So the idea is they're sort of a broker between the hospital and insurance companies, and if you go in for a broken arm or something, they just find the pathway that the doctor needs to follow for insurance to pay the bill. So a few years ago, the federal government passed a law that they're no longer going to pay for hospital-induced infections. So if you go to the hospital and you get an infection, it's on the hospital to pay. And as you can imagine, that's $52 billion or something to that effect a year problem. So we work with the company. We have a data science team where we brought in some of our data scientists, and we work with them to sort of better identify at-risk candidates for hospital protection. Mm-hmm. And we had about 10 years of claims data from Aetna and a number of big providers out there, and they were able to sort of better predict by about 2%, which sounds minimal, but over 52 billion and a couple 100,000 lives, it changes the way treatments are done and is improving people's lives. So it's not just better networking and better ad targeting and these sorts of things. There's like real value in lives.
Mm-hmm. Well, so actually, you mentioned a bunch of use cases. So we talked about healthcare. I guess we talked a little about social networking.
Sure.
Machine to machine. We talked about, I don't know what other.
So I'll give you another example, I guess. We have a banking customer that and this was before it was called big data, but they were very much looking beyond their database to score loan applications. Right, and when the credit crisis hit a number of years ago, and they were refreshing their models very quickly, and what they could do is they could look beyond into sort of your application into social networks and who you're connecting with, and your university and your ATMs, and you'd open up that information. And they actually survived very well out of the crisis, and one of the few banks that didn't get hit very hard because they made smart loans. The other examples that made smart loans were the very small banks that didn't sell them into, they did loans with people they know. But this was a pretty big bank that leveraged third-party data to really create better loans, and they came out of the recession and have actually acquired a bunch of banks and are growing very quickly. So not exactly saving lives, but at least sort of driving the bottom line and changing the way they look at how they issue loans to individuals.
So are other banks adopting that now? Have they used that as well?
Yeah, you see it pretty pervasively. I think that that's a big push. The other thing you see in the bank is the stress test, which is sort of I think it's a federal mandate that if you're a bank and you have X number of loans, you have to run it. I think they do it quarterly or something. It's basically a test to say, is your bank going to fail? Right? And you see a lot of investment in that, and using big data around how do you make sure that we're not over leveraged and there's like a lean leverage.
So there's data collection, data management, data analysis, and we're calling it all big data, but in some ways those are, I don't know if they're separate problems. Are they joint problems? I don't know. How do you see, because I think I get focused on products, and I'm seeing products that collect data, and other products that sort of combine data, and other products that will do analysis. So I guess I'm wondering where we're going to end up. Are we going to end up with 3 separate or 5 or 6 separate classes of data product, or are we going to see some sort of more encompassing software ecosystem that can actually handle the different functions or requirements for big data projects?
I have a view on that.
Of course you do.
Sure you do.
Well, it would be interesting. I want to hear what you say,
Right.
and then I want to hear what
Yeah,
people who actually are on the other side, like using
the
stuff.
real
say.
people that do this stuff. Yeah. No, I think the story today is you do have multiple products. I think you were describing MDM and ETL and all of these sort of animals you shove together to make big data real. Right? And I think that that's the reality of today. It's expensive in a lot of cases because you're buying from these vendors, and their systems are rather expensive. My personal opinion is the trend is collapsing that into very much open source. I think that the ETL vendors of the world and these data transformation vendors that have been collecting data are being disrupted. Hadoop is very disruptive in that it's very low cost, scalable way. You dump everything in there, and you can grind on it in parallel at capacity. So, my personal view is I think you'll see some consolidation of all these different platforms as functionality of some of these open source projects. Will we ever get to one giant system?
Yeah. Well, we don't really have one giant system for anything. But, I mean, it's a good question.
No, it's a great question.
I mean, it's
Or is it going to get easier? I think is sort of what I'm getting at. That, now you sort of end up in a situation where you really need people who have expert knowledge in different disciplines to combine efforts and build something. And whether it's and also even just to look at to normalize data between different data sets. You need to know, in a way, you need a human being to look at things and make an intelligent decision. So I'm seeing all these sort of choke points, like for big data, like the implementations, or a human who's smart enough to know what to analyze in order to put things together. And I think we're all sort of wondering, like, when it's going to get easier.
Yeah, I think the industry will naturally, as it always does, take a tangent and grow many businesses and many different technologies off of big data and make this a huge arena of choices and selections. But I think conversely with that, with the explosion of consumerization of IT, with that continuing growing footprint, I think big data and access to it will slowly become more commoditized. And we have to begin looking less at ways to make the money off of the tools to access the data, but actually making the data more easily accessible and more easily available. You can see the trend, and we're talking about some of the numbers today, how with Windows 8, I don't know, casting dispersions on any Microsoft folks here, but how the Windows 8 was supposed to, well, the hope was to, this explosion of PC purchases, and the contrary has happened. People want their personal devices, their personal systems, their personal tablets and smartphones. We want to consumerize information. We want access to it in our own personal way. And so we have to be careful. Big data for big corporations, yeah, that's always going to be there. But the trend, the growing trend, if you can see anything from the whole consumerization model, that we have to make big data available,
accessible,
and accessible to the everyday person in a way that's very easily
that they can consume it how they want to
consume it how they want to do it. Big data for the big corporations, that's going to be there, and there can be all sorts of data that's crunched and numbers that's crunched, and they're going to make all types of decisions based on that. But again, for the day-to-day person who wants to also leverage big data, but in a very personal way, that's what we have to concentrate on.
Mm-hmm.
So,
That seems to be a lot of your focus.
Yeah. Absolutely.
That's really interesting because
Absolutely.
I would think you have so many silos of government data that would be beneficial for the government to analyze also. But it sounds like your push and your focus is very much to how the consumers are leveraging.
Well, we
it.
certainly have to serve two masters.
Right.
So we have to satisfy that larger government model. But we're funded by the taxpayers, and so we have an obligation to the taxpayers. There's things that they want to see. There are city needs and requirements that they have. So we have to address both.
Should I stop for questions, or should we? I just saw. I hadn't looked up in the last half hour, and I just saw hands raised in the back of the room. So I'm acknowledging you now. You had a question.
Is that okay?
Yes. I decided it's okay.
Protocol here. I just wanted to. I thought you were going down a path, and I want to get back to it for a second because I heard Mike say something about one of the companies you were working with that you kind of brought in some data scientists, and all the talk out there about big data, besides the fact that there's all this technology, is that there's this horrible lack of people that understand. That to me the choke point feels like, at least if you read what's in all the rags, that it's people that know what they're talking about. And I'm wondering from the folks that are actually, that are in the mix, or Mike, you as well, are you finding it, challenging to find people who can do things with this data? And you're a service provider, so you probably love this, right?
Yep.
So I'm just curious on the for maybe on PG&E and the city of San Francisco, are you guys finding there a huge challenge in getting the right people in? And then maybe the other guys can comment too.
I can speak to it briefly. So I was at an event recently in San Francisco. The director from Cloudera, Hadoop vendor, was giving a speech, and he defined. I saw his definition of data scientist is someone who knows statistics better than engineers and who can do coding better than statistician. I thought that's a pretty good one.
I don't know. I know some statisticians who really could.
Except you. But if you're looking for someone who's good at both, good luck. And that's the trick is you're looking for people with all kinds of skill who can code in whatever platform you're using, SAS, SPSS, reporting, MicroStrategy, Tableau, and then statistics, which is hard itself. It's really, and then knowing the business, have the breadth of the and depth of the industry, and then knowing technology enough that when he had have a problem, he knows where to look for answer. It's definitely not easy to find a person like this. I built an analytics team myself. I have 8 people. I recruit all 8 people, and they come from different backgrounds. Some environmental engineers, some computer engineering, IT, some MBA, some have done strategy, quantitative strategy, strategic consulting for a few years. Recruit them, and then knowing their strengths are, develop the areas, sending them to courses, seminars, workshops, and develop areas that they're lacking.
I was going to say they're not coming out of the box like that, right? You really have to find the talent and then develop the skills within those folks.
Yeah, you do, because I mean you don't have people come out. I'm a big data expert. I'm a cloud technology expert. This stuff is too new for you to be expert in it. You take someone who has a broad range of skills and ideologies and technical acuity, and you develop them, and they're able to learn different technologies, because technology is always going to change. So you hear that there's people now who are slated and stated in some of these conferences I go to as big data expert, big data focused person, and this is their business. Well, big data as an ideology has only been around for a very short period of time, so I dare say you would be hard pressed to find an expert. What you can find is someone who has a foundational technical breadth of knowledge and an ability to transform, ability to innovate, ability to change, ability to think differently, and ability to look at technology and apply it in new ways. That's what a big data expert is. So you certainly don't go out and recruit for that. You recruit for people who know a little bit about a lot of things and have more breadth and depth.
And solid fundamentals.
Solid fundamentals.
Big data is a buzzword, but what's going to drive it is the fundamentals.
Absolutely.
Like, the buzzword is just a buzzword.
And there'll be another one in next 6 months.
Yeah, but I think you're onto something with this question about the people, right? Because that was actually why I went and got a master's degree in epidemiology, because I was doing IT in a medical research setting. Doctors kept coming to me and saying, we want to study this. How can we study this? Okay, let's build a database. Let's start collecting this information. We have to figure out what we're going to collect. We have to understand how we can analyze what we're going to collect. And so I see, and then throughout the medical school, other departments started adding, people who could understand principles of data collection and analysis. And I think that those people are going to be the commodity that, not me, but, the people who understand the data that's driving the business and can work with it. I don't know. I personally think that people are critical.
And to your question, as a service provider, we love it or not, we're not sure about we love it or not, but what we're seeing our customers ask is to put not just solutions that just putting together this service and networking. They actually want us to kind of go up the stack, give them a fully deployed Hadoop cluster, but also say, well, we have structured data, we have unstructured data. How do we marry the two? Can we put together something? I was talking to Greenplum. So put a Greenplum cluster, put a Hadoop cluster, put some sort of a connector together, so they can put applications on top of it, so they can concentrate on writing an application to deliver the value for the data that they've ingested, so we can give them in a kind of a cheap manner. So as a service provider, you're right. That's where we're seeing a lot of our customers ask us to deploy.
I can't help but think, right, there's step 1 is collect data. Step 3 is show value. Like, step 2 is where everything needs to take, understand the data, figure out how to format it, figure out how to display it in a way that the average user can understand it.
Right.
And those are going to be the big puzzles.
Yeah. I think that the data science question is very relevant. I think my personal opinion is when there's a need, something will fill it. I think you'll see applications on top that, it's already out there. There's a company, Alpine Miner, that we partner with that makes a dashboard for creating data science workflows where you used to have to program them. You see things like Kaggle, which is a data science competition company that's now opening up its 57,000 data scientists for consulting. There's platforms. We have one called Chorus that helps people work faster in data science. So yes, it's a challenge, and all that people are required, and getting that step 2 is the people, right? But it's not quite as dire as I think maybe the magazines make it out to be, in my opinion.
Actually, we have a question in the back.
If I might be permitted to stir the pot a little bit.
Oh, yeah. Please do.
And first, a compliment to the panel. I took an earlier flight back this year from the airport to hear all of you.
Thank you.
So I'm listening for what's new and hot and disruptive. I've heard a couple of things, but not very many.
Okay.
I mean, a lot of the stuff you've told us so far is way out there, pretty much. So the next little bit, by way of provocation, may I ask, what is it that you think disruptive? So forget Hadoop and Cumulo and Cassandra. This is all out there. This is not new anymore from a VC standpoint, right? This is a VCtaskforce. So please talk to us about what are the real pain points now. Talk to me about data quality. What's going on with data quality for big data? How the metrics changing? What tools or solutions are needed? Just for example, one example, right? On the advanced analytics side, we hear so much stuff about all that needed on. So between R and the SAS Institute and whatever else, what are you seeing that's really at the cutting edge of putting this data to work? Over to you.
Wow, that's a.
Come on, we
There's
did
a
challenge.
lot on our shoulders there with you missing your plane, with you changing your flight and everything. And I don't think we can live up to that one. So, but first, thank you for changing your flight, and I hope that you do gain some value out of this session tonight. But I think you're right. I think technology should be disruptive. I think that we should not do the same things. I think that is boring. I think how to disrupt is you go into new demographics and think differently. And one of the things that we're doing in the city, I'm in the public sector. It's slow. It's very reticent to change. It's slow to adopt technology. I came from the private sector, and I was brought into the city to help shake it up, so to speak. And over the past 2.5 years, we've introduced things into the city and county of San Francisco, not necessarily sexy things in terms of bleeding edge, but the fact that we are doing things in San Francisco that the public sector just does not do. The public sector does not go to the cloud. The public sector in droves the way we have. The public sector does not embrace the open source and open data the way we have. So I think opening up, making yourself more transparent, that's radical. That's different. Putting yourself out there and exposing your technology for opinion, for critique. That's some different change that big data is doing for San Francisco, because we're exposing ourselves by exposing our data to our citizens, because there's some stuff that's come from the rigor of the analysis of the data that has really made San Francisco stop and say, whoa, what have we been doing this for the past 20 years? Oh my God, well, we need to make some changes in this area, and this area, this area. Making that data, stop hiding that data, maybe opening some of the quote unquote whistleblower areas where people were hiding various financials, lobbyist information, that type of stuff. We've now taken the lid off. And so at first we were slowly peeling back the lid, but because of the explosion of big data and the popularity of our opening that door, people are requesting more and more information and more data sets, probably at a faster clip than we can present it on the portal.
But you're probably unusual as a
I'm very
government.
unusual.
I was going to say as a government.
In many ways. But I think that's what makes us, I think, transformational.
Right.
But I think that public sector is kind of the last frontier in terms of change, adopting change, and thinking differently about technology. Public sector has been kind of steeped in old systems, old technology for so long, and the business and our citizenry demands differently of us now. So you're seeing a paradigm shift of more folks who are coming from the private sector or coming out of college and being excited about going into government again because of the transparency and the mandate for such now. I think that's different. I think that's radical. Having radical tools and radical analytics and doing radical things with the data, that's always going to happen. But being open enough to be transparent, that's a very, very, very vulnerable, opening thing, and allows you to be very vulnerable. And it's a very courageous thing to do, to make yourself transparent. So that's one thing that San Francisco is doing now. And there's pluses and minuses to it, lots of caveats. But the win for us is that we've grown and we've been able to spawn new businesses from that vulnerability. Yeah,
Yes, sir. Could you tell us a little about the kinds of data quality problems you're encountering now that didn't exist before?
Absolutely. Absolutely.
Or for that matter, could you tell us about the interoperability of your open source systems with legacy systems?
Absolutely.
What kinds of legacy systems are these? Data models? You're coming towards, I guess there's no universal data model, but any way to go from one kind of data model to another. How are you solving these problems?
It's kind of a magical blend. We certainly still have the city agencies that that are still doing the stand in line, go to the counter, and grab the microfilm off the shelf. We still have that, very much so. And in the same breath, on another floor of that same building, you have folks who have their data accessible, available online, no more lines. They're doing a lot of their transactions are now available and filling out their forms online. So it's a growth process. There is some conflict in terms of presenting that data. So the more legacy data that are in the legacy systems, those are more of a challenge for us to present in a more vulnerable fashion, obviously. So we really have to do a lot of development, a lot of innovation to put those data sets and make those visible. And then, but the more open systems that we can manipulate better, we're able to do that. We're seeking those out. Those are the easy ones. So that's the low-hanging fruit. We want to get to the data, get to the systems that are the legacy anchor systems, the mainframe, the AS400, the HPUX. Yes, we still have that in the city and county of San Francisco as well. But that data is pertinent data. It's tax collector data. It's property tax data. It's tax assessor data. A lot of that data still resides on very antiquated systems that we are upgrading. But we still have to, in its current form, in current format, we still have to make it accessible. And I'm talking way too much. Panel.
We have that problem too. I mean, PG&E is definitely concerned about privacy security issue. We work with SAS Institute, and my team worked with them. It took us, over a month to get the data security check. We're working with Wharton School of Business, where we're doing a kind of a casual outsourcing competition with giving out some of customers' data to researchers around the world. We take some proposals and the data, and after a few months come back with solutions or findings. Yeah, it took us about the same amount of time because they're uploading to cloud, and we didn't have a policy for how do we treat cloud. So everything is evolving as we speak, and it's coming from private sector. The other more normal private companies, I thought this is really like snail. It's moving very slowly, but there's a reason for that because of privacy, all those concerns. But coming back to opportunities for VCs, for other companies, I talk about the small company, startup company in this energy analytics. I do see them play a role, in this economy because the larger companies. One of the interesting is we went through this data warehouse picking process. I did find that many of these larger companies, although they're being, some of them talk about smart planet or something like that, but in terms of understanding the data of utilities or energy, they did not put the best effort. Or I don't know what's the issue. They're still lacking of domain knowledge in terms of tailoring the product to a specific industry. And that required talent, a long time of working together, collaboration, and be willing to say that you're willing to develop. Some vendors come to us and say, we have this product, use it. We said, no, we require a lot of customization. and working together. So you're willing to collaborate and develop together. That's another value proposition. Take SaaS for example. They have forecasting servers. They they're deploying Macy's and retail, forecasting millions of SKUs. But when we're trying to tailor them to if you're trying to tailor them to utilities business, forecasting every customer load, you need to do a lot more customization. For something like this, there's no ready solutions. We still find the challenges too many customization. There's no one company that's providing that. To make it another level, I see there are three types of players in this big data arena. One is like appliance compute infrastructure. The other is like software as a service company. They're addressing specific problems. The third one are companies that are have good models, good algorithms. They're trying to use a tool to solve problems, but they don't necessarily know the business, understand the problem. So in the future, I see the merge of all three. They have to work together. And companies like utility, large corporations, they don't want to deal with several companies. We want to deal with one company so you can address specific problems, but allow enough flexibility so that I don't know what I don't know, so I can explore with data and finding things. So I think that's the trend. That's maybe the opportunity for us there.
We have another question.
With companies like PG&E and the government pushing the big data now out to the public, if you will, ultimately, a good part of which would be structured data. Do you see that the equivalent of a Google emerging for structured data? And what would that look like? Because today, obviously, Google is great for unstructured data.
Following that connection. So what do you mean, like a Google-like company?
Well, like be able to, instead of just type text in it and, hopefully the combination, find you some hit. Would there be this ultimate combined relational database in the sky that's the mere model can start now finding, useful information instead of just returning a whole bunch of text documents?
Did anyone ever use Yahoo Pipes? I may have been the only person who ever used. They had a graphical tool.
Awesome.
What?
It was awesome.
Oh, you used it too, but you could do stuff like what he's talking about.
Yeah.
Like mashups. Like you could query different websites. It was like a drag and drop tool. You could build queries for different websites. So, for example, I did something that. Maybe I shouldn't mention this. Well,
We're videotaping.
Yeah. Well, I did something where I like made a Yahoo pipe that looked at the Billboard charts and then lined it up with the torrents to download the music. So you would get the top 10, and my friends could all go to one page, and so they're.
So that's text data.
Yeah.
Right.
Right. Well, that's all sort of looking for strings.
My own question reminds me of this thing from now 35 years ago for query by example.
Yes.
From IBM.
Yeah.
From the early days of the relational database. Now, not a terribly successful product at that time, and maybe it's not enough for a mere mortal still. Right. So I don't. That's why I asked, what would it?
Where does all the data come from?
But it could be a huge business. Right?
Yeah. That
could be the obvious maturation, perhaps, of the science of big data, as big data as this has become more relational.
Is that the killer app?
And there's that's right.
You should invest in the next school.
Like just ask it a question. No, it's like a smarter Ask Jeeves.
Yeah.
Like you could ask it a question and it would.
You're dating yourself, my friend.
Okay.
Yeah.
Yes.
So sort of along the string of the pot a little bit. One of the things that I haven't heard yet, which I'm surprised that I haven't heard. Maybe it should concern me because my company deals primarily with streaming data, and I think that the evolution of big data, because we've all been talking about stored data, but I think that a lot of the future of big data is going to be how do you handle these sources of massive streaming, data points, whether it's, you talked about a little bit about telemetry, your sub-second sampling of the grid and so on. But you're going to have to deal with, that has to be dealt with. And you can't store it all. You can, EMC would love you to store, every single bit of streaming input that you can take, but at some point it doesn't work. So you've got to either filter it out or you've got to figure out a way to reduce that. And it's interesting that I haven't heard anything about streaming versus stored. And maybe it's just hasn't come up yet. So I'm bringing it up.
Sure. I think, streaming is hard. You're in that industry, it's very difficult. I think that once you insert a human, you've kind of broken the stream, right? So it's really a machine learning play, at least from my perspective, that's what I've seen. And with that comes challenges, right? You're fixed in what machine learning can do today. I think that there are point solutions that do great things. The government has great ones, right, around finding bad guys and listening to phone calls, etc. You're seeing some emerge around social media, so the aggregators and the guys that do dashboards to tell you when someone tweeted your company sucks and things like that. So it's a difficult challenge, and it is part of big data, but it's a very different approach and a very different set of technologies and a very different set of problems. So maybe that's why you haven't heard it come up at this point. But there is a lot of investment going into that. We very often hear, I want to do streaming and I want to analyze streaming, but I want to enrich it with the history.
Exactly.
And the marriage of those two is sort of the holy grail for a lot of companies. And there are folks that can do that with lots of consulting and lots of effort, but I think to the gentleman in the back, that may be an area to look at innovation is the combination of those two.
Yeah, I think with the explosion of there's video cameras everywhere, and security cameras everywhere, and people want real-time access or real-time view into those video captures. We have our police department and our law enforcement agencies. They do have that view into certain areas in the city, and it all comes back into the centralized office. But to your point, how is that data fully managed and stored? Because right now there's a kind of whole ACLU conversation in terms of what types of video data should we allow people to actually see and touch and feel, and do we want people watching other people walk down the street and going about their day to day? So I think the streaming video is still kind of a tenuous walk because of the kind of the personal aspects of it and the regulations around that and the various concerns about personal information, personal data. So from a government perspective, we because those questions have not been answered, we have to kind of respect certain rights of our citizens. But the police use data like that quite a bit, and they use those cameras and they use that streaming information, streaming video to monitor certain areas in the city, and that data is stored, but it's stored for just a certain amount of time. There's some legal city charter parameters around that data, and maybe those things are outdated. I think it's an interesting conversation now to have.
Yes.
I was just going to ask, what do you see as the areas of greatest need? I mean, we've talked about the things that you're doing currently, and we've talked about various trends. And I'm just curious that you go about your day-to-day functions and the different organizations that you work with. What are the big pain points for you trying to get things done, trying to work with these large data sets, or streaming time series, or any of these sorts of things? I mean, what are where are you struggling the most?
Let's get moving. Come on.
Well, where are your customers?
Or your customers?
Yeah, like I said, I mentioned earlier, pain points our customers have is some of these technologies are new. I was just at a large media company yesterday, and they have tons of data, And I asked them, are you guys looking at big data? They're like, no, we don't know how to use Hadoop as an example. So they don't know how to marry the data that they have with their structured data. So I think to be able to kind of educate them or put together solutions that are readily accessible for them is something that is we want to make sure that we put together a platform that is simple for them to use, and they can kind of ingest the data into the right set of either Hadoop cluster or something like Teradata or Greenplum, and then write their applications on top of it so that they can extract value from it. So that's we see more and more of that as we talk to our customers as a service provider.
Leon, you may have some insight on this whole streaming versus non-streaming, like collecting live and analyzing live data versus looking back historically. Like, because I would imagine you've got an awful lot of live data coming in.
Yeah, so I'm in the customer service organization. The data quality we're looking at, tens of terabytes per year for just smart meter data, and then we bundle with other customer characteristics, interaction. At the time, the requirement is not very stringent. Smart meter data is yesterday's meter today. But when you're talking about more real time, is when it comes to grid operations, the sub-second ones. I actually don't work on those, but I would imagine you don't store all of them. You have maybe some kind of complex event processing where you put in some rules to trigger some alarms or whatever alert, and then you analyze them, dispatch, reaction, and then you don't need to store all the data. It probably is not feasible to store all those data in a centralized repository.
I know a big pain point for us is we receive lots of requests for information, and so responding to that need. So we receive requests from all over the world, various media outlets, various citizens, just very everyday people. We have to respond to those requests for information. There's a mandate, a legal mandate for us to do that, and the requests are in the hundreds per month. I mean, it's keeping up with the demands for the data. So, with the advent of technology and storing a lot of data, people know that we have it in some capacity somewhere. Having the capacity and the ability to get the data, speed of delivery to deliver the data requests, that is a growing piece for us that we're working very hard to tame. So we're kind of victims of our own design and success in a way.
But it means it's working.
It's working, and it's spawning more.
Does it mean performance is important?
Performance of the how we get the data, or
you deliver the information?
Absolutely. The better we're able to do that, the better we're able to respond. But we're a nation, or kind of a race of, we want more. Once we do something well, how can we do? I want more. So it's an ever evolving. You never get enough. You're never satisfied. If you give me this, how much more can I get? That's kind of always a never ending cycle for you.
Yeah, I agree. Like, I call it the 5-year-old problem. I have a 5-year-old daughter, and everything is TiVoed, right? So when you're watching live TV, she's like, skip the commercial. I'm telling you, skip the commercial, right? And it's just, Google took a data answer, would you use it?
That's right.
I mean, so we all get so conditioned for instant.
What if it took a data answer, but it gave you a better answer?
I don't know that I would wait. I mean,
No,
you start looking, but you would look at the other avenues that gave you that answer more quickly. And you may very well go back to Google, but you make yourself vulnerable because you lose that business and you go someone else. It's kind of like how they don't have great commercials anymore. You have the commercials, one show ends and it bleeds into the new show. You know.
It will turn the TV on.
Yeah, don't turn off. Don't turn it.
You had a question.
I do have a quick question. So Gina, you actually brought up a good point. So it's to give big data to the user. So my question actually is for them, because the PG&E, I actually get the meter, the thing. I look at it, but I don't know what to do with it. And I don't have no way to ask you to stop sending it to me because I look at it. So what I actually like, what Gina says, if you can give us the user the data download, I can just play with it. Yeah, and make sense of it. There's some way to do it, so that'll be good.
Yeah, I mean, at the back of that, you'll notice there are some generic suggestions as to you can turn the air conditioning set point lower, you can retrofit your installation if you're not already doing that.
Yes.
But it's very generic at this time. And there are a lot of companies and scholars trying to solve, they call it, non-intrusive power disaggregation. So it can break down your usage into different appliances, light bulbs, etc. So it can be more specific addressing, and look at your neighbors that have similar, appliances or similar footage and say what area you should improve first.
Yes.
That one, most of the time they require a current sensor, like seconds or 1 second granularity, whereas today's smart meter is only hourly data. For commercial, it's 15 minutes. That's like the very tough problem. A lot of people are throwing money at that. A lot of VCs are investing in that as well. Whoever can solve that would be a benefit for utility. The utility definitely will be interested in that because it solves exactly your problem. Because we can, if a customer call us and say, "Hey, my bill is really high," we can tell you what may be the reason, the pinpoint.
So what you're saying is instead of doing the hourly check, you do a more frequent check.
Data we have is just hourly or 15 minutes. If you as a consumer you want to pay $200 and buy a sensor and use the service, there are some companies already doing that. But the problem is it costs $200. How many people can do that? So if any company can come up with a method to analyze hourly data with certain accuracy, not very accurate, but acceptable accuracy, that would be great.
More questions? Okay.
Yeah. We'll
Oh,
open
thank
it up
you,
for
everyone.
the panel to be able to meet with the individuals in the audience one-on-one. And thank you very much, everybody. Thank you for joining us. Thank you for taking
I have some words. I'd like to thank Morgan Lewis for hosting us this evening, and I'd like to thank Charlene for putting this fabulous panel together, and let's give her a big hand. Supporting her is Rose Martella. She's a program manager for this program, so thank you, Rose.
Yeah, Rose, you're a big help. Thank you.
And then there's Matt. You are fabulous. You are absolutely fabulous. Thank you so much.
Everyone knows you're in the ring.
And the panel is absolutely fabulous. I learned so much.